let's talk about a Hamilton circuit and the nearest neighbor method. Now remember that a circuit starts and ends at the same vertex. That's important. But the nearest neighbor algorithm, we're going to start by choosing a starting point. So which vertex point are you going to start with? Then we move to the nearest unvisited vertex with the smallest weight, and we repeat until the circuit is complete. But remember, we're not repeating any vertex, and we have to end at the same one we started with. So use the graph below and the nearest neighbor method to find a Hamilton circuit. All right, so we're going to pick a starting point. And in this case, I'm going to pick A. All right, so we're going to start with A and we're going to end with A. So when we look at where we can go, I can go to B, to D, or to E. Well, we want the lowest value, so we're going to go from A to D. And that has a value of 5. From D, I have options. I can go to E or to C. Well, the lowest value there is 9, so we'll go to E, okay, which has a value of 9. And then from E, I will go here, right? So this is really my only option. I know it's the lowest one. But if I go to B, then I'm kind of stuck, so I'm not going to be able to end up at A. So I go here. So I go to C with a value of 2, up to B, value of 8, and then last but not least, back to A, the value of 14. So 5 plus 9 plus 2 plus 8 plus 14 gives me 24, plus 14 gives me 38 is the value of that. Okay, now sometimes we call the repeated nearest neighbor, meaning let's try it again from another vertex. And you can do this for every vertex to see what happens and go for the minimum. So let's just do the same graph, but from a different perspective. So let's start here with B. Okay, we started with A on the last one. Let's start with B and see if our answer is different than 38. So for B, I can go to 14, to 7, or to 8. So I'm going to start with 7. Okay, so from B, we went to E, and that have a value of 7. Now, we really only have one option from this point, because if I would go to, well, actually we have two, either A or, but if I would go to D, just for fun, notice that I would be kind of stuck because I would have to repeat vertices in terms of this piece. But, so I can either go to A or C. C has a value of 2, so let's do C. And then I'm going the other direction. So now I'm going to go to D because it's the nearest unvisited. That's 10. Then we would go up to A, which has a value of 5, and then over back to B for 14. So I have 19, 29, 31. This is 38, which is the same. Is it the same one? B, E, C, D, A, B. B, C, A. That's pretty close. So we could go from every vertex and find the Hamiltonian circuit to see whether or not what's the smallest value. Now we have a traveling salesman problem, which is kind of known in the Hamiltonian world. Because think about if you are a traveling salesman or you travel at all for work, right? You generally want to go back home when you're done. So let's say that you must visit the other 3 cities noted in the graph below. So you live home in Indianapolis. You have to visit Atlanta, Omaha, and San Diego for your job. And if you start and end at home, what's the optimal Hamilton circuit using the nearest neighbor method? Now, remember that I'm losing my words here. We have to start and end, and we don't want to repeat, right? You don't want to go back through Atlanta or anything like that. So when we're starting at home in Indianapolis, and we're saying, okay, where are we going to go first? Well, from Indianapolis, the cheapest flight would be to start and go to Atlanta. So we're going to start by going to Atlanta, which gives us our first plane ticket cost of $489. Now, from Atlanta, we're saying, okay, we can still go to San Diego or Omaha. Well, the cheapest one from Atlanta is to go to San Diego. So we'll go to San Diego for a ticket price of $279. And then the only place we haven't gone yet is Omaha. So from San Diego, we go to Omaha for $417. And then last but not least, we get to go home for $548. Now, when we do that, the total cost would give us $1,733. You could also say then, well, what if we went a different route? What if we started a different way? Well, let me change colors here and just go to a lighter yellow and say, okay, so let's say we started in, again, we started in Indianapolis, but let's say first we go to San Diego, and that cost us $562. And then from San Diego, we went to Omaha, because why not? We can. $417. And then we went to Atlanta, $374. And then we went home, $489. For a total of $1,842. It's still a Hamilton circuit because we used every vertex, started and ended where we were. But it's obviously more expensive than the initial one. So that's kind of the idea of the traveling salesman using Hamilton circuits and all that fun stuff.